Right now, in the next couple examples, what we want to do is we're not trying to solve the equation. We are only trying to find the number that will help us complete the square to solve the equation, like we were pretending to solve it. So again, the first thing we will do is take our 2 over to the other side, and we add 2 on both sides, so it ends up becoming positive 2. Now all we are interested in is the coefficient on the x term, which is 4. So you take 4 divided by 2, and then you square it, which will give you 2 squared. 4 divided by 2 is 2, and then you square it, and that gives you 4. So basically, if we were trying to solve this, we would go ahead and add 4 on both sides of our equation, and then we would go ahead and solve it. But right now we're just trying to determine what that number should be. Okay, so it will be 4 in this case. Let's look at our another example. We're trying to do the same thing. So again, we'll start by moving the 11 over to the other side. So you would subtract 11 on both sides to move it to the other side. And again, we're interested only in the coefficient on the x term, which is 8. So you take 8 divided by 2, and then you square it. Okay, so 8 divided by 2 gives you 4. 4 square will give you 16. And again, that's the same idea. If I add 16 on both sides of my equation, I'll have a perfect square trinomial, and then I can go ahead and start solving these equations. Okay? So this is what we are trying to do here. Now we are ready to look at an example where we're actually trying to complete our square and solve the equation this time. So just like we were doing earlier, we will go ahead and take our 32 over to the other side. So the first step is move the 32 to the other side, and that will give you a positive 32. Okay, because you will add 32 on both sides. So move it over. And now you want to look at the coefficient on the middle term, which will be the m term. So that's 4. You'll take 4, divide by 2, and square it. So 4 divided by 2 is 2. And when you square 2, you end up with 4. So we will go ahead and add 4 on both sides of our equation now. So m squared minus 4m plus 4 equals 32 plus 4. So you'll see we took our original equation and added 4 on both sides. Now you can go ahead and factor out your left-hand side, and this will factor into m minus 2 quantity squared, and 32 plus 4 will give you 36. Now again, if you're not sure on how to factor perfect square trinomials, go back and look at the review factoring section to help you out with this. Okay, so now once you factor your left hand side and you add up your right hand side, you are ready to use the square root property. And by the square root property, you can go ahead and set this up as m minus 2 equals positive square root of 36, or m minus 2 equals negative square root of 36. We know square root of 36 is a perfect square, so you can go ahead and write that down as 6, or m minus 2 equals negative 6. Okay, don't forget that negative sign when you're working with these. Alrighty, now we're ready to solve for m. So take your 2 over, and you end up with m equals 8, or m equals negative 4. Okay, so again, if you want to check your answers, take m and negative 4 and plug it back into the original equation, which was m squared minus 4m minus 32, and see if you end up with a true statement or not. So in this case, we can say that your solution set is going to be the numbers 8 and -4. Alrighty. We'll look at one more example to see how we work on completing the squares. So let's say we have x squared plus 10x plus 18. Again, start by taking the 18 over to the other side. So we will subtract 18, and that will give us x squared plus 10x equals -18. Okay, now look at the middle term. You have 10 as your coefficient. So again, you will take 10, divide by 2, and then you square it, which will give you 5 square, and that of course gives you 25. Okay, so we will add 25 on both sides of our equation. Okay, let's go ahead and factor our left hand side, and that will be x plus 5 squared, and your right hand side will give you 7. Okay, -18 plus 25. Okay, now again, apply your square root property. And again, remember, you cannot use the square root property till you write your equation in this form, which is x plus 5 whole quantity squared equals 7. So you have to make sure that once you get to this stage, then you can apply your square root property, and this will give us x plus 5 equals square root of 7, or x plus 5 equals negative square root of 7. Okay. Now again, you cannot simplify square root of 7 any further, so the only thing we can do is move our 5 over and get x by itself, and we have x equals -5 plus square root of 7. Same thing on the other side, move your 5 over, and you will have x equals -5 minus square root of 7. And again, if you like, check your answers in the original equation, and your solution set for this equation is going to be -5 plus square root of 7, or -5 minus square root of 7. Okay, so that's the solution to your original equation, which is x squared plus 10x plus 18. Right, let's look at this example here. You have r squared plus 3r minus 1 equals 0. Just so that we know that we are on the right track, we'll go ahead and solve this equation by using completing the square, and let's see what sort of solutions we come up with this time. Again, your first step has to be to take the constant term over to the other side. So we'll add 1 on both sides, and you end up with r squared plus 3r equals 1. Now you take your coefficient on the r term, your middle term, and you take 3, divide by 2, and then you square it. Now if you divide 3 into 2, you know you're not going to get a whole number as your answer, so leave it as it is and just go ahead and square it. So 3 squared will give you 9, and 2 squared will give you 4. It's okay if you end up with a term like this, 9 over 4. Just do what we have been doing so far. Take 9 over 4 and add it on both sides of your equation, and you will end up with r squared plus 3r plus 9 over 4 equals 1 plus 9 over 4. Okay, now go ahead and factor your left hand side just like we have been doing so far. Okay, so let's see what this will factor into. You'll end up with r plus, and this will give you, let me see, 9 over 4 will factor into 3 over 2. Okay, again, if you are not sure that this is going to work for us, we can try and verify this answer. And let's see what will happen when we try to FOIL these. Okay, so let's say we have r plus 3/2 into r plus 3/2, and let's see if we come back to this original expression here. So you will end up with r square plus 3/2 r plus 3/2 r plus 9 over 4. 3/2 times 3/2 will give you 9 over 4. Okay, now combine your middle terms. So that will give you 3/2 plus 3/2 will give you 6/2. Okay, and of course if you reduce 6 over 2, you will end up with r square plus 3r plus 9 over 4. And that is what we were looking for, r squared plus 3r plus 9 over 4. So you can see that when you FOIL these, you come back to that same original expression. So we know that r plus 3 over 2 is accurate when you're trying to factor this. Now on the other side, you need to try and add 1 plus 9 over 4. So again, you'll have to find your common denominators and add them together. So go ahead and do that. And you should end up with 13 over 4 as the total on your right hand side. Okay, now let's go ahead and apply our square root property. And that will give you r plus 3/2 equals positive square root of 13 over 4, or r plus 3/2 gives you negative square root of 13 over 4. Okay, now square root of 13 you of course cannot simplify, but you can try and simplify the square root of 4. So that will give you r plus 3/2 equals square root of 13 over 2, because again square root of 4 is 2. Do the same thing on the other side. R plus 3/2 equals negative square root of 13 over 2. Now you cannot simplify it any further, so the only thing you can do is move your 3/2 to the other side. Okay, so we'll go ahead and subtract 3/2 on the other side, and that will give us minus 3/2 plus square root of 13 over 2. Same thing on the other side. Move your 3/2 over, and you will end up with r equals negative 3/2 minus square root of 13 over 2. Okay, so your solution set to this problem is going to be negative 3 plus square root of 13 over 2, or negative 3 minus square root of 13 over 2, because you can see both your denominators are the same. So if you want, you can try and write this over a common denominator, but this will be your solution to this problem, r squared plus 3r minus 1. Okay, so sometimes you end up with answers that look a little bit different than what we have been seeing so far. Right, so let's do a recap to see what were the steps involved in trying to solve quadratic equations using completing the square. Now for your first step, you want to make sure that the coefficient of your squared term is 1. Okay? If for some reason the coefficient of this squared term is not 1, then some other non-zero value, then the idea is you need to divide both sides of your equation by that non-zero number a, because the only time completing the square works is when the coefficient is 1 of your squared term. Now if you start the problem and the squared term has a coefficient of 1, you don't have to worry about anything, you just move on to step 2, which says that you need to write your equation in the correct form, which is that make sure all variable terms are on one side and the constant terms are on the other side, like we have been doing so far. And of course then the next step is to complete the square. Okay, how do you do that? You take half of the coefficient term of the first degree, which is your middle term, and you square it. Then you add that square to both sides of the equation, and then you factor the variable side and you combine the other side where you just add all the coefficients together. And the last part, of course, is you solve the equation by using the square root property.